assignment first.
So here's a question.
What's the difference between these two statements? Like maybe we're trying to follow a path down the try, like that. And some of you are probably doing at least one of these two versions. So, all right, so this is an assignment of one object to another. And if you have your rule of three, it makes a copy of it. And this is also an assignment, but we're assigning a pointer address to something to hold that pointer address here. So that's what it is. But what's the larger ramification of this? Still sounds pretty innocuous. Makes a copy of the object versus copy of the pointer. Are both sort of equally reasonable choices, or?
It's a lot faster to copy of the pointer because it's just a single memory address, but our copy constructors should be designed in such a way to create a whole new kind of object. Otherwise, you end up with whole memory leak stuff. So the first one is far more expensive.
When you say copy of an object, okay, copy of a node. And what does a copy of a node really mean, though?
It means the copy of everything else inside of that node, depending on how big that is.
Of the whole trie.
Yeah, it could
The
be
whole trie, right? So if you're using something like this inside a loop to like descend a tree, then every time through the loop you're copying the entire tree and looking at the next one, and then copying the entire tree, subtree of that, and so on. And when you say it's more expensive, it's like, well, it depends on how big your trie is, but we're talking about, 1 million times slower or something like that, like a lot slower. So the problem is, of course, that this is a reasonable activity to do in languages where these things are actually references instead of objects, right? This is really an object. It's allocated on the stack in this case, if it's in some local method. It's not a lightweight reference to this other structure here, right? It's the whole structure. In C++, more commonly, you might do something like use pointers as ways to peek into some other structure and move along it. So, for example, if I have, I'm still going to make everything look a binary tree, even though it's not. Okay, so I'll go like that, I guess. And we want to follow some path down. Well, maybe you're calling this next. Next is a pointer. You can use it to point to this node, and then you assign it the child one, and it just points to that one. And you follow down, and it points to that one. That's the lightweight reference that you use to traverse and iterate through structures like this. Again, if I use the top one, what are we doing? It would say, all right, next is a copy of that tree. And then when we were down here, and next becomes another copy of this tree. And then we're down here, it becomes a copy of that part of the tree, right? It makes copies all the way down. Shrinking copies, but it's still copies. So anyway, use pointers where we preach the dangers of pointers because you can memory it. But here, this thing is not responsible for this resource, right? It's just taking a peek at it. It's a lightweight way to kind of peek into that structure. So you're not worried about deleting and stuff like that into this. You're just saying, hey, show me that node, give me access to it through this name. Does that make sense? Or questions about that? Now you might not run into it if you do this traversal recursively. You're basically just passing this change thing into, or using that thing as a way to access down the tree. So you might not be doing this explicitly, kind of thing, but it's still happening. Okay, how about this code? It's pretty clean. I want to add a word. I want to add this word. I'm calling it from a trie. This is really a method, even though it's not showing the trie in front of you.
Supposed to say like is a word.
Word? Oh, yeah, right, that's right. That should be word there. Yeah.
I'm like, there's one there.
Yeah. What do you think of it? Oh, it looks dumb. So we're doing sort of double the work, right? Anyone else want to say? So we follow the tree down, decide if it's a word, and you know you don't lose if it is already there, right? So you just return, and then add new. What does add new word do? Well, it says does that branch exist? Does that branch exist? Does that branch exist? Add one in if it doesn't exist. So it's kind of twice the work. Now, a lot of times we say don't prematurely optimize your code. Don't try to beat the compiler. Basically, don't do something fancy to make it run faster. But there are places where I think that something like this shows you don't actually understand the problem that well. That's the danger here. So someone else reading this is going to think, oh, there must be something special about this because we don't want to do this unless this is false or something. They're going to read too much into your code and try to think that there's something else going on here. And so it's not so much the efficiency issue, it's just more the logic is convoluted, right? Even though in some ways it's sort of how you might say it in your head, like, well, if it's already a word, we're done, otherwise you got to add the word in. But this is a very common issue where people add all sorts of special cases to things that aren't special. Add a word would just basically not adding any new nodes if there's no more characters to add to it, right? It would just come back and it would be the same tree. And so don't make special cases out of things that aren't special. It might make you feel safer. You're like, oh, I'm really handling that, empty string case or something like that to say false or whatever. But your code should just handle that naturally. And if you start adding all those layers in there, it just makes it harder to read. So make sure you kind of trim down as much as you can to get sort of the cleanest solution possible. And I'm especially seeing this in your recursive methods, where there are all sorts of very complicated things going on in many of the recursive methods. And so, for example, the find all words with prefix, that's the big one here, right? That's the exciting method of this assignment. Find all words with prefix. And I'm seeing methods that are like 2 pages long here for that. And maybe, anyway, all sorts of special cases and stuff. That's a sign that you need to kind of take a step back and work through it a little bit by hand and try to get a cleaner solution. Without necessarily code, what's sort of like the breakdown of steps to solve this problem here?
Are you asking for recursive?
However you want to, just tell me the step, how would you solve this? So find all words with prefix.
If it's done recursively, you want your base case to be if you find a flag of is a word, return.
You're already like way too detailed, unfortunately. Yeah. I just want
before you start recursing, you need to find the node with that prefix.
all right.
Where to start
Like-
looking after.
Go down along the prefix. This is maybe not a great way to say it, but see if the prefix is there. Right? See if prefix is there. If the prefix is not there, what does that mean? There are definitely no words with that prefix, right? So we managed to get down there, and in our mind, this is our prefix. We got to this node. What's the next step then? Well, I guess you're the one breaking down the problem here, right? So
Then you can use that node to recursively find what comes after it. That is important.
find all words starting at the last. In my mind, this is much quicker to write out. Last prefix node.
Hey, that's my method.
Do any capital letters in there, or is it all? How would you implement this one here?
Find the index that relates to the first character.
Okay, yeah, so we we got this mapping. You're like stuck way in the weeds here. You're like, want to tell me where the semicolons go to or anything, or so. No, I mean, I'm looking for how would you solve this basically, right?
Is this like so prefix is like one whole word in there?
Yeah.
So I'd go to the first character in it and see if that exists.
And then go to the second character.
Colon add the next character.
Okay, so you want to do it recursively, and that's fine. How else can you do it?
Through your prefix.
I mean, if you have a straight path, a little loop and doing something like that, next pointer is this, next pointer is this kind of thing, and looping is pretty clean too. And I don't really have a preference for that, except for if you're doing this one recursively, I think that should be a little helper method. So it's split away and you can kind of solve it on its own. What I see people doing is they have this method here, and they are solving both those in the method, and they're doing it all recursively, and then they have some flags saying, am I still looking for the prefix or not, or am I looking for this one? And it gets really hard to understand what's going on there. And it gets hard for you to debug it probably too, all right? So think about isolating this and solving that, and then isolating this, and again, I would maybe make that a helper method of some kind, right? That goes off and calculates all this and gives you back a vector of strings or something like that. And you'll find, I think if you follow that path, your code will clean up a lot. And again, part of the skill of architecting systems is seeing a problem and breaking it into the pieces that make sense for you to write a function or method about. And in my mind, that's sort of this breakdown. It's not the only breakdown. I've seen plenty of code that works, but it's it's 2 pages long and it's very complicated. You probably spent 20 hours on it or something like that. So sometimes if you feel like it's getting out of control, yet in your head you can kind of say it neatly and nicely, I would think about going back and trying to say it neatly and nicely in your head and then see if you make your code match that style. Then, of course, there's all the issues of just sort of using pointers and things like that, making it all work right. And that's just a syntactical issue and kind of getting that under control, right? But my hope was that you would see similarities between this and stuff you've done in the past, 2420 and so on, descending trees and doing that sort of stuff, and then just trying to figure out the C++ equivalence of doing that, not reinvent recursive methods for yourself, even though you sort of have to do that every time you do recursive methods, and then mix it in the C++ as a complication. So anyway, it shouldn't be getting too crazy, right? It is. What's going on? Let's see if you can simplify something. Any other comments or thoughts about this, about how to solve this assignment, or things that are bugging you? One thing that's coming up maybe that I forgot, seg fault. Did anyone write this? Did anyone do this assignment not get a seg fault along the way at any point? Couple of you, all right.
I ran into it all the time.
What's that?
I ran into it all the time.
No, did not get a seg fault.
Oh, did not? Oh.
This is something company. Okay. Well, good work. More commonly, you probably get a seg fault. Seg fault is basically trying to do something to an invalid pointer, right? And by invalid, either it's like a 0, null pointer, or it's garbage. You don't control it. It's a number in there that you don't know what it means. And this is an initialization problem. And this is something about not just checking to see if you're done recursing or something like that, typically.
So I did have a question about one section of assignment. It was for the copy constructor and then the assignment operator. So I put a print statement in both of them to see how many times they're getting called. And when I used the assignment operator, I noticed that the assignment operator is actually calling the copy constructor. Is the reason for that is that it has to copy the variable into the parameter?
Yeah, basically yes. So the assignment operator, that's the start of it, right? And this is the basis of the whole copy and swap. Copy, and then swap the values, and you were seeing the copy thing happening. So when I say, I have a try that I've made, and I say new one equals old one, then that calls this operator. Old one gets passed here by value. And how do you assign,
Copying it.
it does it by copying it, yeah. So the copy constructor gets called there. So you probably saw that C out first, right? The copy one.
I see it first.
And then you see the C out you had in your assignment saying now in the assignment. So that's, I mean, you're the right idea.
What does it do if you don't have the copy instructor? Does it just copy like the?
Just copies the pointers.
Yeah.
There's a default one that just copies the data members directly. It says assign this to this and this to this. Data members. Which works if you just have like ints and stuff in your class, right? Because saying the int data member equals the other int data member does the right behavior, basically. It's only when you have objects that do that trouble, or really pointers to objects. Anything else? All right. Over there, yes.
Sometimes in like online I've seen for the equals operator, just like that, instead of using just a tree other, they use a const. Kind of reference, I think.
If they do that, so you're saying they do a const reference to other, no copy is happening there. That's the style where you're going to say something like if, is there a pointer there? This equals other, then like return. Otherwise, do this sort of assignment stuff. So this was a common style for a long time. And this line here was basically to say, if you ever said like A equals A, you want to make sure you don't like destroy the values in here before you copy them over. And so there's some stuff like that. But anyway, there are other ways to implement this, and that's the rest of the body should not look the same as our copy and swap. It should look like I'm allocating, like making a new array and stuff like that. The copy and swap is going to become more predominant. All right, my guess is that there are many of you for whom you're going to get this working, hopefully in the next few hours. But it's going to be kind of a little bit messy, a little ugly. And so what we're going to try to do is refactor that code. So refactoring, you've all seen on most of your IDEs, you can do a little right click on something and it says refactor. And what does refactoring usually like to do in that context? Just rename it, right? And that's actually kind of an exciting thing sometimes when you have a bad looking name like X and you can turn it into a descriptive, lovely name and you feel very virtuous from doing that. But it's really not, I'd say that's like the 0th level of refactoring, right? So really the goal of code refactoring is to make a bunch of small changes to the code that basically yield the same. You're not trying to add features, you're just trying to make the code somehow read better. And it's the kind of thing that if you're management at a software development company, you're not necessarily excited about because you're pushing to get the next 10 big features added to your commercial product, and you just say, yeah, I want to spend some time making the variable names look nice and indenting some stuff and thinking about the flow of logic and but nothing's going to change. It's going to act exactly the same. It's something hard to convince people that that's a worthwhile activity. But it basically makes your code base, normally, you're working on commercial products, you're not like starting from scratch each time, you're adding on to something existing. And so if you can somehow make that process of improvement, adding features easier, then I think it's worth the cost of just spending some time making your code sort of read better. So you're looking for confusing code and try to make it simpler. Somehow, again, find the key logic that expresses that idea and rewriting the code to match that, maybe breaking apart, big methods into small methods, all sorts of little stuff. The goal is to make everything more usable and adaptable and make your team more productive by working on this code. So we all know how it is, right? You sort of sit there at the beginning of a project, and you feel excited, you do things right, and then you get about, a few changes into it, and all of a sudden your structure looks like this. And it's hard to avoid. I mean, so for example, even this auto grader that is sort of my curse right now. I inherited some bash scripts from Peter Jensen, and I didn't really like them, but I sort of stuck with them and added in some unit testing on top of that. And so I thought that'd be more formal. And I look at it now, and it's the most awful, hacky mess you can imagine. I mean, it really is just like no one else can like understand what's going on, and I sort of don't understand anymore what's going on. And so, anyway, I was at this point, I'm now at this point, and now I'm sort of at the refactoring stage where it's like, okay, what have I learned from this? What can I do, better? I'm not sure I have any great ideas about it, to be honest, but hope springs eternal, right? Another comic, can't hardly read it. Nobody knew what's in this big and messy class, therefore we decided to refactor it. You rename it to Area 51? Exactly. So, no one knows what's going on there. Well, look at that whole storming thing going on. Tomorrow? I thought it was today. Tomorrow. All right. Do you all know talk about that internet thing about people wanting to go storm this secret base and see the aliens? Do you know the local version of this going on? Yeah. It's computer services. What is it? No, that's not it. That's going to happen. Yes. There's another one in town that's going to happen.
It's from the old restaurant.
That's okay. I'll put that one too. There's even another one.
If it makes anyone feel better, there is legitimately a Wikipedia article for Storm Area 51, They Can't Stop All of Us.
So the other side, like what I'm talking about is on 13th South, there's like a preschool thing that's really weird looking.
Yes!
There's a whole thing going around a while ago about that's really like a front for the CIA or something like that. And they're like, no, I've seen a kid there once. But anyway, people are going to storm that building. That's what's going on. Not really. But I'm glad to know that other one's also happening that I was unaware of. Okay, so Kent Beck, who's sort of famous in software engineering circles, basically started the whole JUnit, next unit kind of style unit tests. Coined something called code smells. And we'll talk about code smells in a little more detail, just because it amuses me so much, the name. And basically, it is code that doesn't have to necessarily have a bug, but it basically shows some structure that reflects poor design. And there's sort of these like things that people have identified that are indicative of sort of troubling architecture that makes it hard to maintain this in the future, or future risk of things. And so we'll talk about this code smell idea a little bit. One common one that's even sort of too common in the sense that everyone knows about it is duplicated code. So why is duplicated code bad?
Because if you change it in one space but don't change it in another, then the change is not going to propagate in the future.
Yeah, there's consistency issues there, basically, right? And it just takes up space, and all this stuff. So where does duplicated code manifest itself? Like where do you start to see it, I guess, or I don't know. It's hard to answer that question, I guess. What's that? Inheritance is a reasonable way to avoid duplicated code, and so is composition, which is added data members to the class.
Copy and paste programming?
Yeah, well, certainly if you get tempted to copy big chunks and paste them somewhere else, that's the first sign that maybe you should try something else. And what is something else that you should do instead of just copy and pasting those big chunks of code? make some sort of function or method out of it, right? I'd say in the try, there's some parts that are like temptingly close to being duplicate code, like descending down for the is a word versus the prefix stuff. And anyway, some places there you can maybe find some commonalities. I already talked a little bit about another code smell, these sort of like unnecessary logic checks, right? Like you have a loop that goes from for int I equals 0, I less than num, I plus plus. Sometimes you'll see people say like, if num is less than 0, do something else, and then do this loop here. But this loop's not going to run if num is 0, right? It already fails out because 0 is not less than 0, and so this loop won't run anyway. There's like an else here or something like that. So people have this sort of special case stuff that's just handled naturally by the logic of the loop, and just gotta be careful just adding that to your own security blanket, kind of your stare to it or something like that, right? Just keep it simple and make sure the code handles what it should handle. All right, so the next assignment is gonna work with this idea. And the next assignment doesn't start until you actually finish this assignment. So even though you're working on pairs here, just because I say, hey, this next assignment, work in pairs, if you're still working on this current assignment, don't like pair up and start like, using each other's code at this point. Right? Finish this thing off. So I have on the assignment page well, it's longer than that name. I don't know. It's University of Utah, CS-3505, blah, 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 something, fall 19 or something like that. So we're an organization this class is an organization in GitHub, more specifically in GitHub Classroom. And there's a link, and if you click on the link, it'll make a repo for you once you sign in to GitHub. So both of you need accounts on GitHub. One person accepts that link, and then you invite your other teammate onto your team on that project, right? And then they can get access to the repo as well. And you're basically supposed to work together to, one, refactor your code. And instead of using a node pointer array, I want you to I know all you people desperately use a map. Finally, your day in the sun has come. And I want you to make it a map of a letter and a node. Okay? And then consider what that means for the rule of 3 sorts of things. And then I want you to really work with each other, not just kind of skim and say, yeah, it still works, that's cool. But like, clean up all this grotesque recursion you have. And think about making some helper methods. And think about your variable names. And add a few comments. And try to make it like the best code you can imagine making, kind of thing, right? This is a chance that's kind of not, you desperately just try to pass some tests on the autograder, but instead, think about, this already works. And how can we just make it more readable?
Are we refactoring both people's codes or just one set?
Right, so you should pick the one that seems like it's working best. So for example, if your code's not working, look carefully for a partner. Don't have 2 people whose codes aren't working. Well, maybe you can still learn. I mean, no, you can get it working, right? 2 of you together that can make this thing happen. Especially with this transition here. But just kind of pick one. Don't fight about it, My code's better, my code's better. Just pick one. And then we're going to use something called Google tests. You're going to write some tests for the code. So instead of my autograder testing it, you're going to have your own tests. One of the reasons for this is actually I want you to do the Google testing stuff first. See if your code works according to your tests. And then as you refactor it and make changes, you can keep running the tests and say, okay, it still passes the test. I think I haven't broken anything in my efforts to clean up the logic or do those kinds of things. So it's important to have this baseline of tests available so that as you make changes, you're not inadvertently actually changing the behavior of the program. In fact, that's one of the big goals of unit tests. Why they have them running all the time on projects is basically let people change stuff all the time, do all the changes, but you want to make sure, you know, they haven't broken something. Let's see. Partner stuff means you really should be working together. Hope best is in person. Set up some sort of chat thing if that's all you can get going. But it's not like you work on it for an hour and then you're going to have like conflicting views of code, just go back and forth, refactor each other's code into your own opinion kind of thing. I think you'll find, I mean, you've done a lot of partner stuff at this point in your life, right? 2420, 3500. So there's upsides and downsides. What do you like about working in pairs? 4 eyes. Are you calling me? Come on. 2 pairs of eyes looking at the code. And it's amazing sometimes how that you see stuff, right? I mean, you can look at something for an hour, but having someone else bounce that off of can be very effective. Even as you're writing code, maybe slightly annoying, but also helpful. Someone can say like, "Oh, you forgot to put a type name here, or you forgot the semicolon." You know, the stuff that ID kind of helps you a little bit, but you just kind of get moving along a little faster. What's a downside of working in a pair?
Sometimes distribution of labor doesn't,
Yeah, so fairness issues, right? And yeah,
just like syntax and other differences.
some of it's right. I mean, there are many ways to express ideas, and if you want to use an iterator and they want to use a for loop, then you have to kind of fight about that for a while instead of just doing one of them and seeing how it goes.
Conflicting schedules.
Yeah, and sometimes it's not even like division of labor, but it's just finding time to work together is hard, right? And that's the thing to ask when you're trying to find a partner. Hey, I am busy from 8 in the morning to 10 p.m. on Tuesday, Wednesday, Thursday, and I'd rather work on Friday. See if that matches up a little bit.
This might not apply as much at school, but sometimes I feel like 2 people working on the same thing, like maybe those people could be working separately and get more done. But
all right, so that's a common question about pair programming. We have 2 people, and we're basically turning into one person. Are we having our productivity? As far as I remember vaguely reading in various studies, that is not really what happens, right? Your actual productivity is even more than 2 working independently. But I can imagine it varies depending on how that team is working, right? Code style. In a larger place of business, you might have a more set code style you have to follow, so there's less bickering about that. In this class, you'll probably have some different opinions.
Will you write issues and commits?
What's that?
Will you write issues and commits?
So just the way you document kind of your commits to GitHub and stuff. Some people are just going to say fix bits, other people try to write something more substantial. I will say, so you should push up, as you refactor, you should push up your changes every time you sort of do something, right? I changed this method, push it up, add some comments. We're going to try to read those as a little diary of your refactoring process. So if it just says code sucks and then all done, we kind of lose the thread. I have one more question. I'm now a perfect student, and my initial code was perfect. What is left for me in this assignment? Not perfect. That's the first thing to think. Maybe you're not as perfect as you think. Your partner can tell you that. Try to find something to adjust.
Pick a bad partner.
Pick a bad partner and use their code. Wow, that's bold. You are the perfect student. Wow. I'm sure there's something you can do, right? And if you just claim you're perfect, where it looks extra hard as your code and try to find something we object to. So. Let's see, anything else with parts of this? Submitting, to be honest, I'm a little unsure. I have never used the GitHub submit for Gradescope. So I think that's probably what we'll do. Maybe that's something else I need to do about it. So anyway, it's likely to be something like that, but I'm not 100% sure.
I used it on assignment 1, that worked fine. Assignment 2, because the whole file structure and the include, it didn't let me keep the include in the source that I had set up, but it worked fine for a few.
Yeah, I'm not really expecting any use of this. You actually like try it once, but I think we'll just. And I can't remember. I know that sometimes you want to commit a particular or submit a particular snapshot. You know, say this is the one that's my final one. I can't remember that capability that way about. It's due next Thursday. And to be honest, it's not that bad. I hadn't rewritten mine in that map style. I spent like an hour poking around with it, trying to remember some stuff with how maps work. It cleaned up a lot just from that. I didn't actually change anything else because my code's perfect. And then using Google tests can take a little bit of, learning how to use it as a unit tester, but it shouldn't be that bad. So it's mostly just try to find a nice solid block of time with your partner for an hour or two to kind of get rolling, and then meet again. So you can probably wrap it up that second chunk of time.
Comment and then a question about Google testing. Notice how many hands popped up when we said, what are the bad things about working with pairs? Well, they're a lot more numerous than
The productivity.
Yeah, right. But, so what is Google Test in a library or?
Yeah, I'm going to talk about it next.
Okay.
No, I understand. The pair stuff is it's painful, but we got to figure out this part because we're going to go to groups pretty soon, and then I think the pair stuff is bad. The group stuff is dramatic. And the other thing is like use Piazza. I'll try to add some more info. Piazza I need to make public a find a partner discussion on Piazza, and basically there just try to add stuff and then give some details about your workflow, and I'm a perfectionist, this will punch you if you get anything wrong. Try to say something about how you like to work with people, and then if you make a partner, probably delete yourself off there so no one's still trying to contact you about it. I think it has some built-in mechanisms on the Piazza side to help that out a little bit, but I don't quite remember. All right. Testing. Testing is hard. You think it's writing code is hard. I think now that I'm writing all the autograder stuff, like, man, testing's a lot harder. And I don't know if you felt that in the past, because you've written unit tests in hopefully Java and in your 2420 and in 3500. Are tests involved in that whole sequence? Units of tests, right? And I think one thing that's hard about tests is that it's easy to write a few tests and kind of be satisfied, and it's harder to know when you're done. But it all comes, I think, with practice. Now, there are some studies done on the software development lifecycle. While software engineering has all of the acronyms, and they sort of try to measure the cost to fix defects. And so I'm not sure what the cost is exactly, whether it's person hours or just sort of contractual money amounts or what. But if you can, the baseline is sort of fixing your requirements. So they make sense, right? And then architecting the thing. If you make a nice design, kind of helps things along. Mistakes there are harder to fix than requirements. Coding, even more expensive to fix things. If you're sort of done coding, it's all in testing. You find errors, you may have to go back and fix earlier things, so it just gets more and more expensive. And then they claim it. These numbers are kind of made up to me, but some sort of business study came up with this. But the longer you wait to catch errors, the more expensive it is to fix. We're going to catch them as soon as we can. There's actually a lot of different styles of testing. When I say styles of testing, I mean things defined even by the International Software Testing Qualifications Board. Like you can take, certifications and these kinds of things. And unit testing is what we're familiar with, where you're basically testing the low-level behavior of just specific pieces of code. And then a lot of them also become larger, like how do pieces integrate together? And then how do users respond to this overall program? And then, maybe it works, but it's too slow, especially if you're in some area where there's performance requirements. Maybe you're making a self-driving car, and you better hit be able to update once every millisecond or something like that. So you need to make sure that works okay. So anyways, a lot of different kinds of testing, but we're mostly, for the most part, still sort of stuck in unit testing because that's a well-defined kind of thing. That's my little method to see if the output matches what you want for certain kinds of input. There are different styles of testing, so you can test the static code base, right? You don't run it, you just sort of look at it somehow. And code reviews have a role in this, where basically people are looking and saying, hey, that looks like it's a logic error here or something could be going wrong. And there are compiler tools to help you with this. So when you compile it, not run it, you can say stuff about type mismatches or undefined behavior and so on. And then there's basically, you run your code and you have some programs to do some sort of vague testing of how things work, or a framework that gets that a little more formal. And then even with testing, there's different ideas of how you should examine it. So there's black box testing, where basically you aren't supposed to really know what the code looks like. You basically know the specification and then what the expected outputs are. You basically test that without sort of knowing the internals. And then there's white box, where basically you're supposed to be looking through the code and make sure you're sort of testing all possible execution paths and code coverage kinds of issues. And both have their role, basically. White box testing obviously lets you know a little bit more about how testing should be structured, but in some ways black box testing also kind of, one, you might not have access to the internals, but also kind of forces you to think more carefully about exactly what you should be testing without sort of depending on the code you guide that. We'll look at a few C++ tools that I think sort of fall into some of this category. If you add the -WALL warnings all flag, it's a pretty handy flag to have. It gives you a lot of information about like type mismatches, things that might be allowed under C++ but are kind of a bad idea. And typically they're pretty easy to fix. You just go through it and make them clean up, and it's a good practice to get into. Pedantic basically means a lot of compilers, they implement the C++ standard, but maybe have some other things in there that have sort of grown up over time that seem useful. And so that only allows you to use the strict standard. And then, to be honest, I don't quite understand. There's a W extra that has a few more than all, so I don't know exactly what that means, but I've read about it, I just can't quite remember the point of that. Some of you all seem more common. There are things in the C++ language you can do that help enforce certain kind of logic and testing. So there are asserts, and asserts basically stop the execution of the program if they're ever not true. All right. So you could, for example, if you had some string or something, an array, you can say assert the length should always be greater or equal to 0. And that's pretty much true, right? And so if that is ever false, something has gone terribly wrong in your program, and you should basically say, I can't recover this. This is not like an exception that's thrown that I can recover from. It is something that is totally unaccounted for, and you should just get out of there. So the program quits and gives a message saying that this assert failed. People use them to document program logic. So the assert style, for example, comments, where on a function or method, you say, here are my expectations of what's true coming into this method, and everyone calling this method should follow those rules. Well, it doesn't really there's not a whole lot of enforcement in a comment, right? So one way to do that is you add asserts that say, are all these things that you believe are contractual obligations of the precondition of this method actually true? You just list them out. If they ever fail, someone is broken the contractual obligations there, and the program's not going to work as expected. So you can fill your code with asserts. You can actually make them compile out by doing a no debug flag on your compilation. So basically your testing phase would not have that flag, and then when you're ready to release it, you add in a no debug flag, and it will get rid of all the asserts. So there's no performance penalty. And the rationale there is you want to put in locks when you're sort of developing the program, and then just sort of not make it possible for it to happen during release. I think asserts are kind of cool, but I basically never see them anywhere in code. And I'm not sure why people haven't picked up on as much. Have you used them in other contexts or
Python.
Python?
I've seen them in Python for sure.
Let's see, is that a different thing? I'm trying to think where Python.
I've seen that they work the same way. I've been using C++.
I think in Python you gotta be a little more careful because like there's no sense where that data is at all, right? And so that's one way of checking sort of type safety almost or something like that.
They use a lot of TypeScript, like the JavaScript TypeScript.
People using there?
Yeah.
Yeah. Anyway, it might be just a cultural thing, right? That people aren't really using, but I think give them a try. Add something to your code and see if you. I mean, maybe one problem is you basically never actually trigger them because they only happen when really bad things happen. So, like, you never see them execute. You think they don't have any value, basically. So, maybe that's the. As some kind of example, you can imagine in a doubly linked list, you're going to assert that where I am in the list should be equal to going forward and then going back, as long as you're not at the end of the list. And if those aren't the same, something is corrupted in those forward and back arrows under doubly linked list, right? So that basically defines what it means to be doubly linked, that you can scoot back and forth. And if you ever hit some place where this actually triggers, your list has gotten corrupted. And it's important to remember when that happens, it's not because someone typed in a number that, cat when you're expecting something else. It means that, there was an actual programming error that corrupted that list somehow. So it's not, again, it's not like an exception. Someone typed in something weird and made some data act strange. A fundamental principle of the doubly linked list is that you can go forward and go back. And if that's not true, you have some flaw in there. But I think it's, again, it's sort of like you're supposed to be writing your code and all of a sudden like, it'd be really bad if this were to happen. Let's assert that that's not true. It's a little hard to think of how to assert those in there. And maybe in the try copy constructor, you want to assert that after the copy that your child's not the same as the other child at that point. They're not the same pointer, right? And that could have told you something maybe earlier on in the debugging process and just waiting for the seg calls and then trying to figure out what's going on. So anyway, I think I'd love to see a big C++ program just like totally loaded down with asserts and kind of see how to use them effectively. Then a more common thing that we're all used to are these unit testing frameworks. You write little tests, fires them off, and basically sees if things returning from functions or from methods are what you expect. And it's a way of making things more formal, right? So when I was before the autograder, I used to write a whole bunch of Python scripts to test homeworks, and they were also fairly sketchy in their niceness of code, lots of system calls and other great things. And it's sort of nice then to take that mess and just sort of random Python programs and turn it into a framework where you should have some expectations of behavior and make it easier to run for other people. So what we're going to use is Google Test. It comes out of Google. And I would say unlike, like Java with JUnit tests and stuff, there's a whole bunch of competing unit test frameworks for C++. People like to reinvent them for some reason and think that theirs is better than someone else's. And probably some are better than others, but my interest level in that is not too high. Google seems like good enough for me. So we're going to use Google Test. The way you get Google Test is you find their repo and you clone their repo and you end up with a file structure that looks like this. Somewhat surprisingly, it is Google Test / Google Test. Then inside that Google Test / Google Test, there's include. And inside include, there's another folder gtest, and then Google Test.h. And then, they just updated this. There's a lib folder now that these libraries are inside. So there's an include folder and a lib folder down inside here. All right. So at this point, it acts like libraries we're used to including, where if I have my project over here and I want to do something with Google Test, I need to have a big I path to the include folder. And I need a big L flag to the mysterious missing lib folder. And I need to do a -L gtest and a -L test main. All right. When you run a unit test program, it doesn't want anything to do with your own main method, right? Your own main function. In fact, you can't have a main function. I'll try to run that as a main function. But just makes just work with a couple things. And so a unit test program would need a main that fires off all the unit tests somehow. Instead of us writing them, they've provided their own main function and compiled it into a library. So somewhere there's a main.cpp, and they turn that main.cpp into main.o, and then just because that wasn't enough, they turn that single main.o file into a libtest main.a. But all this does is provide the main function that fires off your program. So when you're compiling something here, you're going to have your own, try.cpp, and you're going to compile it with libgtest and libtest main, and none of those look like they have a main function inside them. But this is the main function here. This is the thing that runs the unit tests. Okay? If you have your own main function, it's going to compete with that, and it's going to be your redefinition main.
So I have the Google test repository pulled up, and I'm not seeing the libgtest.a.
Oh, you got to make it.
Okay.
So it's just the source code. And both my sign instructions say how to make it. So anyway, just think of this just like when we were doing the libhybrid stuff. It's the same kind of process. You use the library, big I flag that includes, big L flag the libraries, name the libraries. 3 things. Right? I'll get there. Inside the test, you write assertion. So it looks a lot like other unit test frameworks. And you basically say, hey, I want these two things to be equal. If they're not, it takes this message that is inserted into the test, which is a really freaky format to me, and prints that and shows some stuff about failing, but that's not true. So if it's true, it moves on, and if they're not equal, it does this and fails the test. Okay? But no, so some of you are probably used to doing comma in some message string here for the failed test. Instead, we're using this insertion operator and inserting it into the test, which must be some kind of stream thing. I don't know. Hard to imagine why they did it like that. If you hit an assert and it fails, it stops all the tests inside that test block. You can do an expect, where it basically keeps going and just finishes the block. I tend to use expect more often just because when we're doing stuff like grading tests, you want to see all the little tests that run as much as you can and not just fail everywhere. There's a whole bunch of asserts, also expects. Equal, not equal, less than, less equal, greater than, greater equal. There's assert true, assert false. And if you're doing like Boolean expression comparisons, you use assert true and false, not assert that this thing is equal to true or this thing is equal to false. That'll cause trouble. So if you're doing true false stuff, use that. You can force it to fail, so you can basically put inside a if statement. If it does the true part, it fails, like it's never supposed to go in there. So you can do some fancy stuff if you want. With that, I'm a little confused as to what the difference is there. And you can do some stuff with throws when we start doing exceptions. Sort of typically, the expected value goes first, and then the actual value goes second, although I think they've changed their messages to make that a little less, more balanced. You can kind of put it either way you want now, as far as I understand. But I still like, a lot of unit tests have that idea of the expected value first and the actual value second. Let's try the test. Okay, I'm going to include gtest/gtest.h. That's going to be the first point that's a little confusing. Where am I? Here, for example, CD. Okay, so I'm in Google Test. I go down into Google Test again. In here, I have an include folder. So I CD into include. Inside here is the folder gtest. And in here is gtest.h. There's a lot of legal stuff. What I expected. And then this thing basically just includes other things. So, here's my question. If I had done, in my compiling, I'm at the same level as Google Test. I can do that, find my way to the include folder, and then in my code, I included gtest/gtest.h. And of course, the combination of those two things says, take this and add gtest, gtest.h, and look for the file along its whole path, right? That's what those two things mean in conjunction, -i and whatever I put in the strings up there. So why make us do that? Why didn't here I add gtest, and then I could just say include gtest.h. So let's try it actually first, maybe, and see what happens. So I'm gonna get back up to and I'm going to try to compile this first of all. It should work actually. Okay, so it's C++11, and I'm going to create an output executable test. I'm compiling lecture 10 in class. I got to change that name. I should go back for a bit of time on this. Okay, so lecture 10 in class. And then I do a -i flag saying go into group test, include, and I include gtest/gtest.h. And then I do the same thing for my library, and then I list the libraries, and also group test is multi-threaded, so I can use the pthread library as well. That should just be on your system already, so don't worry about that. All right, so I compile that. Compile, it's great. Now let's try the alternative and make the path be more direct, kind of like what we're more used to doing, like just including the header file directly, right? So go down to the gtest folder and then tack on gtest.h at the end of all that path. I didn't say this, so let's start the test again. I got an error and a more mysterious error. So it says, in file included from my CPP, this file. So it found this file for me. And there's a fatal error. Cannot find gtest internal, gtest internal, .h. Why could you find that? And it found it a minute ago.
Because your U-I specifies only the gtest directory and had to go out to the had to go out and find the gtest directory.
When it's looking for this, it pastes this path stuff onto what I specified here. And so it's include gtest, gtest again, and then internal gtest.h. So there's two gtest folders in a row listed there because I listed it up here, but their own internal mechanism always has that gtest folder in it as well. So sometimes basically what I'm trying to say is you got to follow whatever standards that library are using, how they include their own files and match it, because usually they're going to include other things as part of their process, and you can't fight that basically. So by realizing they already include the folder inside their includes, it means we should not include it on our include path, and instead just do what they do and use that folder as part of our include. Now, I think it's not so bad actually having this, because in some ways, even though this is really the only file we ever include, with other libraries, if you're including stuff, maybe it's kind of nice to have some overall name like gtest in front of everything. So gtest-numbered.h, gtest/ something else.h, and it kind of tells you that they all belong to that gtest library. So having that little organizational thing doesn't seem so bad. All right, so anyway, if you feel tempted to cut that short there and just add to the include path, it's not going to work that well there. And notice I got spirit of like making sure I can do it by myself here, so I have in the comment here remind myself what has to happen. All right, so we have a function called factorial, and I want to test it. It's also recursive, yay! So we're all happy with recursive stuff now. Gtest, you make these test blocks, and a single test block can have several asserts inside it, basically. And there's some sort of other hierarchy that I really am not like ever using. So this first thing you put in here is sort of like the group of tests, the name for the group of tests, and the second one is more the specifics, like handles, positive input or something like that. So some sort of descriptive name about what kind of thing I'm testing. And then I can say expect equal, thank you for that. And then I already forgot the expected value. Okay. So that's enough to build up a test. And save that. Compile it. And run it. And you get sort of the usual, both informative and mysterious information from the unit tester. So I ran one test for one test suite. Just doing a test here, handle positive input, didn't take much time, and it passed. Ran, okay. And then it gives a summary as to the overall kind of number of tests pass and fail. What else should I test? Let's add some more here. 2. Yeah, I think that's a great answer. Start with stuff that you know what the answer should be, basically, right? And that will start to, this is a base case, so we want to handle the recursion or something like that. And while I'm on a roll, those numbers all look a little suspiciously the same, so I'm not going to convince anything happening here besides returning the input value or something like that, right? So let's try factorial of 3. And let's let it fail just so we see a failure here. Oh. Now it didn't say much. I should have said something, I think. Oh, up there. Yeah, I was like, expected equality of these values to factorial 3, which is 6. This is why on autograder we're all staring at it going like, what is it trying to tell me, right? Because one problem is that I typically have them do this off on some other chunk of code and save to some temporary value. So instead of say, expected quality of these values, 2x, which is 6 or something like that, and you didn't know where that x came from. So that's what we have to learn with autograders, how to kind of get more information about that. But it's telling me 2, and to call the factorial with 3 in it, it computed 6, and it expected 2. Of course, the 2 is the one that's wrong, not the expected value in this case. And then it tells you that one test failed, and it keeps telling you that over and over again, essentially, just so you really get the point. All right, so 6. Let's add, what else should I do? All right, get your tested brains on here.
We haven't tried negative, but we do know test.
Negative. So let's stick with 0. I don't even know what a factorial of negative should be. Especially my recursive code is negative, so.
Is it time for a search statement, perhaps?
Yeah. So test, and I'm going to put this in the same family. And then handle 0. And here, expect equal 1. And we should have an error message here. Don't forget the 0 case. That's not a very great error message, but we'll get something out of that. All right, so if I run it this time, now it says there's 2 tests. Again, the tests are the blocks, not the individual asserts. They all passed. Maybe I'm thinking that. Let's see what the error message we get. And up there, it gives the typical quality check and then some sort of message for that. What kind of stuff do you think you should put in here? What have you done in the other unit tests? What kind of things did you put in there? You ever write any messages to your unit tests? In some ways, sometimes it can kind of feel a little redundant, right? Like if I said failed factorial 0, then it's going to say the exact same thing that the built-in message is going to tell me. But I think you start doing a little more complicated stuff, it's good to put in something that says how you arrived at this failed condition. Let's see. I was going to change this, so now our test suites are different. Basically, the only difference is, 2 test suites are ready now. So anyway, I don't expect it to get so complicated. We have like multiple test suites typically are in our code, but certainly in larger code bases you have. I think it'd be different files at that point too.
When you fail a test, does it throw an exception that we could print like a stack trace of?
So it returns how main returns 0 on good, it returns some other value on fail, and you can interpret that. For example, my bash scripts can read that and say, let me have it. It doesn't say where, I can't capture where it happened. I'm expecting this looks a lot like other testing things you've seen. The only real complications are getting that G-test installed, stuff you love with libraries, trying to find libraries so the compile line works, and then just the nuance, whatever subtleties there are in how G-test works versus other kind of testing functions. So I mentioned this, yeah, just use expect false. So this thing returns true or false. Don't say expect equal to true or false. And then if you have a double or float number, you can have a tolerance. So you can say as long as this is equal to this within some very small number, they count as being the same, and that's because floating point numbers have inexact representation, and so they're likely to not measure exactly the same as being equal. So we run some selfies. Here's some code. How do you start thinking about what to test? Like, you start spinning out stuff, and what's your mental process for this? Test. Okay, so you look at the specification, and then that gives you a lot of clues as what's going on. I think that's a great way to start. Look at the specification. Sometimes you even have some examples in there that should produce this, and you can make those into tests. If you're doing white box testing, you look at the code. If you have like if statements, make sure your tests trigger both cases of the if statement, right? So is a word true? Is a word false? Make sure both those are being exercised somehow. You have loops. Try to trigger going through the loop kind of normally, or maybe a case where the loop doesn't run. Try to figure out ways to exercise different pathways through your code. And typically I kind of think there's some kind of like common cases, the factorial 2, factorial 3 kind of thing. And once you get 2 or 3 of those down, I don't think you have to push it much more than that. Edge cases, sort of extreme value, maybe 0, negative, things that happen on the boundaries, empty string. And then, hard to think of these sometimes, corner cases where there's a combination of edge cases. So if you have something that takes in multiple parameters, you can try an edge case for one parameter and an edge case for another parameter, see if you get a corner out of it. What's another approach to testing besides this sort of like us enumerating various inputs and thinking about the correct answers? What's another way of kind of think about developing these test cases? Anybody?
Write some tests.
What was that?
Write some tests before you code.
Oh, well, actually, okay, that's a whole different way of coding. So, test-driven development is, a very interesting way of coding where you write a test and then you write enough code to match the test, so you return the correct answer. You write another test and you write code to match that, and at the end you have the nice set of tests and hopefully code that's been well thought out in terms of matching specification. But I meant more instead of like thinking about like, oh, let's write 2 or 3 tests for a common case, write 2 or 3 tests for this. There's a whole other way of thinking about taking tests. So fuzzy testing, has anyone heard that? Fuzz testing, I mean? Basically, you just send like a million things at it and see if anything sticks, basically. So you just try all possible combinations of things. It's a little hard to know how you know what the right answer is in that case, but sometimes it's effective for that. All right, so look at the assignment spec. Finish up the current assignment. Find a partner. It'd probably be good if by Monday or Tuesday you have a partner, right? If you don't have a partner by Monday or Tuesday, let me know and see if I can find some other people for you to play the matchmaker. Yeah. You basically need to have a partner. And yeah, see what you think about looking back at your code or your partner's code. All right, we're done.